In this lesson we're going to look at how to calculate the total surface area of a three-dimensional object. Now for a three-dimensional figure we need to calculate the total surface area by taking into account the individual component surfaces. So for example, if we look at a cylinder's components, we see it consists of two circles and a rectangle. Now that rectangle is wrapped around just in the same way that a soup label is wrapped around a can to form the cylinder. Now notice that the length of the rectangle from here to here, when it's wrapped around in a circle, that will be the same as the circumference of this circle. So that means that the length of our rectangle is the same as the formula for the circumference of a circle, 2 pi r. And the width of the rectangle is h, we'll call that h, which is the height of the cylinder. So the area inside, the area of a rectangle, which is normally length times width, becomes 2 pi r times h. Likewise, the area of a circle is pi r squared. So the total surface area of the cylinder, the formula is going to be 2 pi r squared, because we have two circles, and the 2 pi rh was the area of the rectangular label that was wrapped around the cylinder. Now we can rewrite that formula by factorising and taking out a common factor of 2 pi r, so we could use the formula in this second form, 2 pi r bracket r plus h. So for common 3D shapes, the formula already takes into account the various component surfaces. But there are occasions that require you, that's you, to separately calculate each. Example, calculate the total surface area of the structure below. Now we've got the distance 2.5, which goes across the top of that dome. And that's going to represent the diameter of that sphere. And we've also got 2 meters over here, which represents the height of the cylinder. Now the total surface area formula for a sphere is 4 pi r squared. But we don't have a whole sphere, we only have a hemisphere or half sphere. So we'll halve that formula to give us 2 pi r squared and calculate that using the radius, which will be 1.25. Now we'll assume that we're going to include the base of this cylinder. So if we look at the total surface area formula for a cylinder, which is 2 pi r squared plus 2 pi rh, we'll use that formula, but remember, because the dome is sitting on top, we no longer have exposed that surface which represents the top of the cylinder. So instead of 2 pi r squared here, we'll only need a single pi r squared. So we're effectively customizing the formula to make it fit our shape, a cylinder including the bottom but not including the top circle. When we calculate that using the radius of 1.25 and the height of 2 meters for the cylinder, we get 20.62. So now it's just a matter of totaling that up to give 30.44 square meters. Let's have a look at another example. Let's find the total surface area of the ice cream shown. Now we're assuming that the ice cream consists of a cone which is topped by another hemisphere. Again, looking at that cone, we can see that this distance of 5 centimeters here represents the diameter of the sphere, so the radius again would be 2.5. The total surface area for a sphere, the formula is 4 pi r squared. So we have a hemisphere, so we halve that formula, which is 2 pi r squared, and we'll calculate that using a radius of 2.5. That gives us 39.27. Now the total surface area of a cone is pi r bracket r plus s. Now that's the factorised form of the formula, but you can also use the formula in this form. Pi r squared, which represents this flat circular part of the cone, and pi rs, which represents the curved surface. And that s, by the way, means the sloping edge length. Now the thing is, we don't need the flat surface because we've ice creams topped. The cone is topped with a scoop of ice cream. So that means our formula just becomes pi rs. So we drop the pi r squared part here. So calculating that curved surface, we replace the radius with 2.5, and the sloping edge length of the cone was 8 centimetres, as shown over here in the diagram. So that gives us a total of 102.1 centimetres squared.